Lesson 13.4 is going to focus on the law of sines, but before we get to the law of sines, we're going to be looking at the area of a triangle. When we are given a triangle with angle A, B, and C, remember angles are the capital letters, and the side lengths little a, little b, and little c, we can determine that the area is one of three things. All three of these values will be the same. Either area is 1/2 BC times sine A, area is 1/2 AC times sine B, or area is 1/2 AB times sine C. Notice in each of these, A, B, C, B, A, and C, A, B, and C. All three values are used, or all three letters, only one is capital. The other two are the lowercase sides. So it's the angle and the two sides that are adjacent to that angle. Those are the ones used to find the area. Now if you'll remember back from geometry, you might say to me, but Mr. Anderson, area of a triangle equals 1/2 base times height. And I'll say, well, yes, you are correct. That is 100% true. But when we have a triangle and we are not given a height, we can determine that the height would be dropped down directly from the top point. In this case, we would say our base is C down here, and our height, I'll just say H, is this line. Now if you drop it straight down, it's going to create a right angle right at this point, in which case now we have a, use a different color, we have a right triangle that we can be working from. In this right triangle, we have sine A, or a angle A, should I say, in which case we would say sine A is opposite over hypotenuse, so H over B, our height over our length B. And so if we wanted to solve for the height, we would say B times sine A equals our height. Put our height back into this place right here. B sine A. Our base, right here we said was C, so we'll get rid of that one right there. So now we have area of the triangle equals 1/2 B times C times sine A. That's where this one came from. You can derive it multiple ways. If you were to use a different base instead of C, if maybe you wanted A to be your base over here, and then this would be your height, same thing. You would do a similar type of derivation, but all three of them, any way you go, will give you one of these three area formulas. So now that we know how the formula of an area of a triangle works, let's try it out. If we have, in our first case, the triangle ABC, with AC being 9 centimeters, AB being 9 centimeters, and angle A being 40 degrees, again, we just punch that in and say area of the triangle equals 1/2 9, we got from this angle, times 9, or that we got from this leg, and this leg, times sine of the angle in between them, which is 40. I'll give you a second to punch that in on your calculators, but mine is showing me area then equals, actually I'm going to do that squiggly line, is approximately 26.0 centimeters squared. Make sure you're saying centimeters squared, because it is an area, it's not a length. So the area of this one is 26.0 centimeters squared. Let's go on to this case over here. We have 12 meters, 15 meters, and the angle in between them is 58, so we'd say area equals 1/2 times 12, which came from here, times 15, which came from here, times sine of 58 degrees, which was our angle. Again, I'll give you a second to punch that into your calculator. Mine again is showing me area, again, approximately going to come out to 76.3. This time it's meters squared. Again, you always want your units squared because it is an area, not a length. So that's how finding the area of any triangle would work. Now let's get on to the actual law of sines. This is one of the most powerful and most useful formulas or laws in all of trigonometry. Law of sines is used to derive many other formulas, many other policies used in trigonometry. And basically all it says is if we have angle A, angle C, angle B, and then their corresponding legs on the other side, little b over here, little a, little c. When we pair two of them together, like the sine of a over little a, that proportion is going to be the same as the proportion, or the ratio would be the same as sine b over b, and that's going to be the same as sine c over c. Now the cool thing about this is, if you don't know C or angle C or leg C, you don't need that. You just need the sine A over A and or the sine B over B. So we can use all of them. We can use just two of them. You really only need two of the fractions to work with. And technically, because they are all going to be proportional, you could say these flipped around as well. You could say A over sine A equals B over sine B equals little c over sine c. Both of those are true representations of the law of sines. So let's see how the law of sines actually applies as we are working it out. Remember, you only need two of those fractions to work with. So if we need to solve a given triangle given two angles and a side, the first and probably the easiest thing to do here is, remember, any triangle has 180 degrees, so we can subtract the other two angles, so minus 100 and minus 53, and we'll find our missing angle here, in which case that's going to come out to 27. So we know right off the bat that this is a 27-degree angle. So we've got 9, a missing value C, and a missing value A, and we have all of the angles already paired up. So, going by the law of sines, we would say then that the sine of 53, which we got from over here, sine 53, divided by 9, which is this piece here, that proportion or that ratio is going to be the same as the sine of 27, which, remember, we got from right here, over A. If A was over here, we have our A value over here. Now, to get A alone, we just cross multiply and divide. So we would say A times sine 53 equals 9 times sine 27. And we just need to divide out sine 53, 53, those cross out. We're just left with A equals 9 times the sine of 27 all over sine of 53. I'll give you a second to work that out on your calculator, but on mine, that's telling me that A is approximately 5.1 units. We don't know exactly. Doesn't mention how long each is, so we can just say units. So we've got one piece done. We know our A value. Now we need to figure out our C value. So to do that, I'm going to get some of this stuff out of our way. Oh, losing our 27 there. Try to leave it in that spot. All right. Again, we'll set it up with sine of 53 corresponds with 9 over sine of 100 corresponds with our value c. So we cross multiply and divide. C times sine 53 equals 9 times sine 100, and divide by our sine 53 on both sides. Crosses out. We are left with C equals 9 times sine 100, all of that over sine 53. And on my calculator, that's coming out to approximately 11.1 units. So we have all three angles. We have minus one leg. A was 5.1 and C was approximately 11.1. So using the law of sines, we solved for that entire triangle.